Good evening, everyone. Welcome to O-Level Physics. Today we'll be going through structured questions for this topic of DC circuits. Okay, my name is Mr. Chu. Today is the 1st of May, the last day of this month. And let's begin. Okay, everybody start doing this question. Question number 7. Okay, begin. Okay, begin. Okay, all of you give me your answer together. Don't give me part by part. If not, it's quite hard for me to follow. I got the first answer in already. Oscar, your first question is incorrect. Try again. Okay, only Oscar have attempted part A. The rest of you have not given me the answer yet. Okay, Ryan, your A is incorrect. Your B is question B is in hold on. Incorrect as well. Okay, Ryan, try again. Okay, Oscar, your A is correct now. Well done. How about the rest of you? I'm going to call you all to go and do on the screen. Who need help? Can you type help in the chat? Okay, Bei Kwan, your answer A is correct. Well done. Ryan, your A is correct. Very good. Now you got it right. How about Qiao Xing and Yuting? Level 2 of you for part A. Okay, start doing. Okay, Ryan's B is correct. Oscar B is correct. Okay, Yuting A correct, B correct. Yuting, your C1 is correct. Bei Kwan, your B is well done. Qiao Xing, where are you? Why you got no answer yet? Okay, can I have Oscar do part A on the screen? Okay, Ryan, can you do part B on the screen? Okay, Yuting, you do. Okay, sorry. Let me. Okay, Oscar, you do this one. Ryan, you do this. Yuting, you do this. Qiao Xing, your A is correct. Well done. Okay, Bei Kwan, you do this question. And Qiao Xing, you do the last one. Okay, all of you do that on the screen right now. Okay, Oscar and Ryan, are you doing the question on the screen? Okay, I just realized that my screen went up. Okay, Ryan, please try. Okay, so for part A, so far all of you got the correct answer. So I will just not go through. I will not explain part A. The answer is 24 ohm. Okay, Ryan. Ryan, can you give me the answer for part B? Okay, for Yuting, you need to explain why point A is 3 volt. Okay, why the potential here is 3 volt? Why? Okay, so how do I explain that? Let me write down here. Okay, as both resistors have the same resistance of 30 ohm. Okay, so the EMF of 6.0 volt is shared equally between the two resistors, giving a potential of 3.0 volt at point A. Is that clear? Okay, most of you also got the part B correct. So I'll give you the answer for part B. The answer for part B is 0.25 ampere. Okay, so for part C, this Y part, you need to explain like this. Okay, you understand now? Okay, so write something like this. Now for part C, part 2. Okay, these two are incorrect. I want to see your working. Okay, can you see that? Okay, so for Pei Kwan, can you see over here? This resistor is 10 ohm. This resistor is 30 ohm. So these two resistors are different. So this 6.0 volt EMF will not be shared equally between these two resistors. So how will this 6.0 volt be shared between these two? It should be in the ratio of 10:30. Is that clear? So how do you split this 6 volt between these two? It's in the ratio of 10 ohm over is to 30 ohm. Okay, so basically it's 1:3. Clear so far? So you want to find the value of point C. Okay, point C would be 3 out of the total of 4. So for point C itself is 3/4 times the whole PD or the whole EMF, which is 6 volt. Is that clear? Okay, this working not so good. Maybe I can write something like this. It is 30 over 10 plus 30 multiplied by 6 volt. Okay, this 30 here is this 30 ohm resistor. The 10 plus 30 is the total of these two. Okay, so this 30 will actually takes up 75% of the whole thing. 10 will take up 25%. They are in the they are actually shared proportionally. The EMF of 6 is shared proportionally. Since this is 3 ohm and this is 10 ohm, the PD of this 3 ohm will be 3 times of this 10 ohm. Okay, so you use the formula 30 over 40 times 6. You should be able to get 4.5 volt. Everybody understand how to do question part C2 now? Okay, if you understand, please give me a clap. Okay, give me a clap. You understand? If you don't understand, give me a no reaction. Then ask me which part do you not understand? Right, Beikwan, you okay? Okay, Ryan, Beikwan, are you okay for part 2? Okay, let me erase this part. Okay, so now you all know that at the bottom here is all 0 volt. Okay, you know that if I tap at A, it shows 3 volt. If I tap at C, which is 4.5 volt. So if I were to put a voltmeter, okay, between these 2 points, what would the voltmeter value show? Will be the difference between the point A and C. Clear? So you're already convinced that A is 3 volt, C, okay, C is 4.5 volt. So the difference between A and C would be the answer. The potential difference between these two will be 4.5 minus 3.0, the PD, and you will therefore get the answer of 1.5 volt. Okay, so for part 3, if you understand, give me a thumbs up. Okay, up to here, this type of question, do you all find it challenging or you all find it fun and easy? Do you all find it hard or do you all find it okay? Okay, can you type out your reaction, your feeling about calculating DC circuit so far? So most of you are just average, okay, meh, right? Why you meh, you become sheep. Can we do a bit more? I'm sure you'll be able to master this topic. You'll realize that it's not that hard. Once you understand, you don't need to memorize so many things. Okay, let's continue. Okay, all of you start doing 2A. Part 2 is 1 mark. Okay, start doing this. It don't take too long. Okay, Oscar, for part A, your answer is correct, but your degree of accuracy is wrong. Okay, try again. Ryan, your A is incorrect. Oscar, your part 2 is correct. Okay, Chelsea, your A is correct. Well done. Bei Kwan, your A is incorrect. Okay, Oscar, your A is correct. Very good. Yi Ting, your answer for both is correct. Okay, so can I see who can I ask to volunteer? Oscar, can you do part 1 on the screen? Yi Ting, can you do part 2? Bei Kwan, your part 1 is correct. Well done. Well done. Where did Ryan disappear to? Okay, Chelsea, well done. Okay, Oscar, you might write something at the back here. Okay, very good. So can you see over here? This is 2SF. This is also 2SF. And your final answer cannot be more accurate than your working, correct? So final answer here should be also 2SF. Okay, so for division, we use SF. If it's addition and subtraction, we use DP. Is that clear? Okay, so for this question, your formula is correct. In your working, you may want to choose to use the accurate answer. Maybe the 0.9061. Okay, you may want to use the more accurate answer in your working. Then your final answer, you put to 2SF. Is that clear? Can that be done as well? Okay, well done, Yiting, well done, Xiaoxing. The rest of you, are you able to do this question? Okay, if you are okay with this part, give me a yes reaction. If you need me to explain further, give me no reaction. Ryan and Oscar, are you okay? Ryan, thank you, Ryan. Oscar, how are you? All right, let's go to the next one. Okay, start doing this. Ryan, since you scared messy, you do typing. Okay, start doing. Okay, right on the screen. Okay, there's nobody have answered so far. Come on. Yiting, your part one is incorrect. Oscar, your part one is also incorrect. Okay, Xiaoxing, your part one is correct. Well done. Incorrect. Okay, if I were to redraw, maybe you'll be able to see better. Okay, the resistance of R2 okay, the resistance of R2 is 10 ohm. Okay, So the bottom part here, it mentioned is 3.2 ohm. So the top part here is 3.2 ohm. The bulb is also 3.2 ohm. So can I redraw this thing into like this? I have a 3.2 ohm. Okay, sorry, I'm wrong. This is not 3.2, huh? The 3.2 is below. Okay, so this part is 3.2 ohm. So the top part here will be 10 minus 3.2 will be 6.8 ohm. So the top part is 6.8 ohm. Then it breaks into two parts. This is 3.2 and this is 3.2. So can you see this 6.8 and 3.2 combined become 10? So your R2 is this and this together. So when I break this down into this kind of circuit, does it look like this to you? So from here, are you able to calculate the total resistance? So you calculate the parallel first, then you series add with the series. Then can you calculate the answer? So everybody try it again. Okay, Xiaoxing got the answer correct for part 1. Ryan, can you state your answer for part 3 onto the screen? Use annotation. Okay, let me just draw 8.1 to for you. Okay, so for part 3, what's the advantage of 8.2 compared to 8.1? Okay, Bei Kwan, can you do again part 1? Your answer is incorrect. You try again part 1. Okay, Yu Ting, your part 1 is correct. Well done. But Yu Ting, why do you use a formula? The A times B over A plus B. This one is a mathematical formula. You memorize. You memorize that formula. I will not recommend you to memorize, but not wrong to memorize. Chelsea, can you write your answer onto the screen? You're waiting for who? Okay, so can you see over here? This part here, the effective resistance is 1.6 ohm. Okay, so this is 3.2, 3.2, and this is 6.8. Okay, so the bottom part, when you calculate, you get an effective of 1.6 ohm. And now the top part, 6.8 and 1.6, they add together in series. And therefore your answer will be 8.4 ohm. Is that clear? Okay, so how do you do the question? The total resistance is equal to 1 over 3.2 plus 1 over 3.2. Okay, plus 6.8. Is that correct? So you will get 1.6 plus 6.8, and therefore you get 8.4 ohm. Okay, so for part 1, are you all clear? Before I erase the drawing. Okay, so let me erase all this. Okay, sorry, Chelsea. Can you write the rest again? Okay, the PD across the length when the slider is at A and then at B. Okay, when the slider is at A, you're supposed to give a value. Okay, so give a value. What would be the PD? Okay, when at A, right, it will look something like this. Okay, it will look something like this. Okay, so when the slider go to A, are you convinced that at the top here is this is 12 volt, this is 0 volt. So can you see here? The bottom point here is 0 volt. The top point here is 12 volt. Therefore, it will become 12 volt. Is that clear? Now, what happened when I slide until the bottom? Can you see this? When you slide to B, it'll be like this. So you all know that this is 12 volt, this is 0 volt. Sorry, I draw again. So you have the resistor here. You join to the buck. Okay, so you know your battery is 12 volt on top, 0 volt below. So at this point is 12 volt. At this point is 0 volt. This 0 volt covers a lot of place. Let me highlight to you all where does this 0 volt highlight join to. Okay, let me show you all the highlighter. So from here, your highlight from here to here to here to here to here. Can you see all the green color part will be 0 volt? Are you convinced about it? All the green color part are 0 volt. So at the top here is 0 volt. At the bottom here is also 0 volt. So therefore at B, it is 0 volt. Is that clear, everyone? Okay, I want all of you to clear a reaction. If you understand part 2, give me a clap. Ryan, Oscar, you okay? Okay, finally, for part 3, what is the advantage of this 8.2 over this 8.1? What is the advantage? Okay, Ryan gave me an answer just now. Ryan was saying that in 8.2, using a potentiometer enable the user to vary the amount of resistance by the resistor. Okay, you are just explaining what is a potentiometer. And that allows the user to change the brightness of the bulb. Okay, Ryan, your answer is not wrong. Okay, what you say is not wrong. Okay, the potentiometer, when you slide from A to B, it allows the bulb to have a different brightness. But same for figure 8.1. If I change the variable resistor, my PD of this bulb will also change. So my brightness of this bulb will also change. So both of these setup allows the bulb to vary its brightness. So why is 8.2 have an advantage over 8.1? Okay, so my question is, why would 8.2 has an advantage over 8.1? Okay, let me give you a clue. Okay, let's go back to part 2. Can you see that for figure 8.2, you can let your bulb to have a very high voltage, you'll be the brightest. And then it also allow you to go to 0, you'll be off completely. Your bulb will be off completely when it is at B, because the PD will be 0, then there will be no volt, therefore the bulb will be off. But now look at this. This variable resistor. Okay, if the variable resistor is 0 ohm, okay, it means that your bulb will have high voltage, become bright. Does it make sense? When this is 0 ohm, the EMF will be totally used up by the bulb. So the bulb have the maximum PD and they have be the brightest. Understand? However, how high can this variable resistor be? Maybe 10,000 ohm, maybe 1 million ohm. So regardless of how high this is, there are still some resistance here. Is that clear? So if there's always some resistance here, the vote will never be zero. The PD of this bulb will never go to zero. And when it never go to zero, it will not be completely switched off. Are you all clear about this? Okay, so this variable resistor can only go up to a maximum of certain value. Even at the maximum value, the PD across this bulb will not be zero. So this bulb can still dim, but it will not dim to nothing. Whereas for this example, when you slide down to B, there'll be no PD here, there'll be no current flowing through here. It will become off. The bulb will switch off. So for 8.1, you can never switch off the bulb. But for 8.2, you slide to B, the bulb will be switched off. For variable resistor, you change the resistor to very high, you only dim it to very dim. You will not cut off the current completely. I know it sounds very complicated, but do you understand now? Let me give you the answer, then you copy down for reference. Okay, are you clear about part 3? If you are clear, give me a thumbs up. If you are clear about my explanation for part 3, give me a thumbs up. Thank you, Ryan, Oscar, and Yiting. Chelsea and Bacon, are you okay? Okay, I hope that subsequent question, you all will be able to answer me. Because the feeling that you all gave me for the past 2 questions is you all are still not very clear, which worries me. You all want to still see the answer? Okay, let me go to the next one. Okay, very good. You all may start doing. You start doing. Oscar, your A is correct. But take note of your significant figure. Yiting, your A is correct. Well done. Okay, Oscar, your B part 1 is correct. Yiting, your B part 1 is correct. And Yiting, your B part 2 is correct as well. Oscar, B part 2 correct. Well done. So only Oscar and Yiting can do. The rest of you, where are the rest of you? Where are the rest of you? Okay, only Yuting and Oscar is giving me the answers. How about the rest of you? Okay, who is need help? Type help in the chat. Okay, Pei Kwan need help. How about the rest of you? The other three of you haven't given me the answer. Okay, let me go through this question with you. Okay, so this circuit uses a light dependent resistors. Okay, so for a start, let me zoom in. Okay, so this resistor on top here is fixed. This is variable depending on the light. Okay, so can you see when there is bright light, it is 600 ohm. Clear so far? So ignore the V out. Ignore the V out. What happening here is you have two resistors. One is 8,000 ohm. The other one is 600 ohm. Okay, how is this EMF of 12 volt shared between these two resistors? You'll be shared in the ratio of 8,000 is to 600. Is that clear? Next, you know the point below here is 0 volt. Okay, to find this point here, the potential of this point, okay, you need to use 600 over the total. The total is 8600 multiplied by the entire EMF, which is 12 volt. Is that clear? So 600 over 8600 times 12. And because you can see over here in the question, everything is to 2SF. Okay, this one is 2SF. This one you don't know, it can be 1 to 3SF. Okay. And in this equation, okay, this voltage also 2SF. So it's safe to give your answer that is not more accurate than what is given in the question. So you look at your calculator, you should get 8.4 volt to SF. Okay, so at this point, okay, wait, I'm sorry, I do wrongly. Not 8.4, it's 0.84. Sorry. Wow, very, okay, I write again. So, do you need me to draw again? So basically, on top is 8.0 kilo ohm. This is 600 ohm. How is this EMF of 12 volt shared between these two resistors? You'll be shared proportionally in this ratio of 600 is to 8,000. So bottom here is 0 volt. So this point here, what is the potential? The potential will be 600 over a total of 8600 multiply by the entire EMF, which is 12 volt. From here, you should be able to get the answer of 0.84 volt to significant figure. Okay, so the answer here will be 0.84 volt. Okay, Pei Kwan and Ryan. Okay, and Xiao Xing, do you understand now? Ryan, Xiao Xing, do you understand now? Ryan. Okay, so let's continue. Now that you know how to do this, all of you do part B now. Part B. You may begin. Begin. Okay, do part B, 1 and 2. Are you doing? Are you doing? Okay, so now this V out is 8 volt. It means that at this bottom point is 0, at this point is 8, at this point is 12 volt. So if I were to do a voltmeter between these 2 points and these 2 points, this will show me 4 volt, this will show me 8 volt. Am I right to say that? So the resistance will be in the ratio of 4:8. Okay, 4:8. So the voltage across the fixed resistor will be this value here. 12 minus 8 will give you 4 volt. Correct? Next, what is the resistor LDR? You know that the voltage is now 4:8. The resistor also will be in the same ratio of 4:8. So if this is 8 kilo ohm, this will be 8 over 4 of 8 kilo ohm. The value below will be 16 kilo ohm. Is that clear? Okay, so that the ratio will become 8:16 will be same as 4:8. Understand? So the 4:8 will be the same as 8 kilo ohm is to 16 kilo ohm. These two ratio has to be the same. Okay, 4:8 volt is always the same as 8 kilo ohm is to 16 kilo ohm. Understand? Okay, if you all are clear about this, give me a thumbs up. Ken, Pei Kwan and Ryan, are you okay? Okay, let's go to the last one of this question. Okay, do part C. The output now is connected to an electronic switch and lamp. The lamp switches on when the V out is larger than 8 volt. So this now connects to a switch and a lamp. Okay, and the lamp will only switch on when the V out is larger than 8. So the position of the LDR, oh, okay, these two things swap. Describe and explain the operation of the new device as the level of light fall. Okay, what happened? When there's more light, the resistance will drop. Clear? So how do you do this? Any of you need help? Type help in the chat. Meeting, you give me the answer, then ask me for help. Okay, we need to redraw this thing because the position are swapped. So let's redraw so that easier to see. So how do we do this question? Okay, so in bright light, okay, in bright light, what happened? Okay, in bright light. Okay, in bright light, this will be 0.8 volt. And then this will be 11.2 volt. Correct? So when it is in bright light, this V out Okay, so let me explain to you. Based on the way you answered earlier on. Okay, in bright light, PD of the LDR is 0.84 volt. So therefore, the V out will be greater than 8 volt. The lamp will switch on. Understand? Okay, the lamp will actually switch on. So as the light level falls, the resistance of LDR will increase. Okay, so when this LDR increase, this voltage, okay, the proportion will also increase. When this increase, this value here from 11 will drop until a point where it's below 8 volt. Is that clear? Okay, so V out will decrease. And the brightness of lamp decrease. Okay, are you clear about this so far? Okay, so when light reduces to a level that the resistance of LDR reaches 4.0 kilo ohm, okay, V out will actually become less than 8 volt, and then the lamp will switch off. Clear? So when this resistance drop until 4 volt, can you see over here? When it drop until 4 kilo ohm, the ratio is 4:8. When it's 4:8, it means that the voltage will be what? 8/12. Yeah. So this one will be this will become 8 volt, and this will become 4 volt. Clear? So when this value becomes even bigger, this 4 will drop, this 8 will increase, and when this 4 will increase, and this 8 decrease, and then your bulb will actually switch off. Okay, up to here, are you all clear about this? Okay, if you are clear about this, give me a clap. I'm still not confident that you all know what's happening. Okay, let's continue. Oh, just nice. Okay, who would like to try and draw on the screen this 2-mark question? Easy one. Come, anybody? 2 marks. Who can volunteer? Raise your hand. Those who can volunteer, raise your hand. Someone. Let's quickly. Someone who like to do, raise your hand. Okay, Bei Guan, can you try this question on the screen? Okay, well done. Very good. Everybody able to do this? Let's continue. Okay, let me clear the thing. Okay, so you all see the answer. Okay, that's correct. So the switch is now closed. The current in lamp P is 0.25 ampere. So the current is 0.25 ampere. And there's a potential difference of 1.5 across its terminal. Okay. So if I put a voltmeter here, it will show 1.5 volt. So calculate the resistance of the lamp. Okay, very simple. Okay, quickly do. How do you find the resistance of lamp? This one is too easy really. Okay, Yi-Ting, well done. How about the rest of you? This is not hard. This is a very simple question. Oscar, incorrect. Okay, Oscar, well done. But your accuracy is incorrect again. The rest of you, where are you? Too tired. Okay, we finish this as the last question. We still got part C and D for this. Then we end today. So can you please give me your fullest participation? Okay, let's do it quickly. Quickly do part B. B is very, very easy. Okay, you all know the formula V over I. Just put in the answer, put in the value, you get the answer. Is it very hard? Hurry, hurry. Okay, so you all want to play waiting game, right? Xiaoxing, Beihua, and Ryan. I already put down the formula. I give you all the two value there. Just plug it in and give me the answer. Why are you all not giving me the answer? You want to drag this until what time? Okay, if you all want to wait, we all wait together. Beihua, your answer is a wrong accuracy and no unit. Oscar, your answer also has the wrong accuracy. Can you give me the right answer? Okay, well done, Beihua. Oscar, well done. So left with Ryan and Chelsea. What's the answer for part B? Part B. Quickly, quickly give your answer. Thank you, Chelsea. Well done. Left with Ryan. Ryan, are you there? We think why you got answer for C1 so fast. Ryan, we are all waiting for you. Okay. Maybe I can start to dismiss students already. Ryan, we're all waiting for you for a very simple answer. Do you think your C is correct? Can you think for C part for D part 1, you're supposed to explain. Okay, Ryan, are you there? We are all waiting for you, Mr. Ryan. Okay, Ryan, later you stay back. Okay, the rest of you, let's carry on. Okay, before I continue, let me give you all the answer. V in this case is 1.5 volt over 0.25 ampere, and therefore you get the answer of 6.0 ohm. Okay, remember, put it to 2SF. Okay, because your original answer is all both in 2SF, your final answer will also be in 2SF. Is that clear? Okay, the last page for today. Okay, all of you do part C now. You think got it correct. Okay, for you think, or for D part 1, the question is, why is the current in lamp Q larger than the current in lamp P? Let me draw the thing for you. Simple one. Not exactly the same. Can ignore the switch as well. Okay, this is a simple drawing. Okay, start doing. Okay, so for eating, you need to talk about the current in R and the current in P. How are the current in P, Q, and R related? Okay, can you explain that? Oscar incorrect. Xiaoxing incorrect as well. Okay, this part here, I put in blue. 1 over 18 plus 1 over R, whole thing inverse. So this part, This part I use black plus R, then total will give you 12. Okay. So make R the subject. Make R the subject, and you're able to solve this question. Okay, so this blue color thing, you end up with R R plus, okay, wait. Okay, R plus 18 over 18R inverse plus R equal to 12. Then you change the inverse out, will become 18R over R plus 18 plus R equal to 12. Then you make R the subject. Okay, you make R the subject. You do. Okay, you do. Eventually you get the answer. Okay, I'm so sorry. I'm so sorry. I made a mistake here. The resistance of P, as we calculated earlier on, we know the answer for this. This is 6 ohm. Okay, this is 6 ohm. So therefore, my R here should change to 6 ohm. I'm so sorry about that. So let me just change. This becomes 6. This becomes 6. This becomes 6. This is 6. This is 6. Then can you make R the subject now? Okay, this is the answer in part A. Okay, so you got 18 times 6 divided by 6 plus 18. So you get 4.5 plus R equal to 12. Your R itself will be 7.5 ohm. Okay, so the answer for this is 7.5 ohm. Okay, because the answer for this, the resistance of P is 6 ohm as calculated in part A. Clear? Okay, now, why is the current flowing through Q, this one, IQ, is greater than the current flowing through P, IP? Okay, let me explain to you, and then we'll end the class shortly. I still want to see right after the class. Okay, so for this question, you just need to write down. Okay, let me write down. IQ is equal to IP plus IR. That's all. You just need to explain that the current of Q is the sum of IP and IR. If there is current flowing through R, IQ will always be greater than IP. Is that clear? So that's the answer for D part 1. Okay, last question. Lamp Q, this one, has a different resistance from lamp P, even though they are identical lamp. Okay. So this is 7.5 ohm. This is 6 ohm. Why do they have different resistance, even though they are the same lamp? Okay, by right, if you see the word identical, their resistance should be the same. Okay, the resistance should be the same. Let me read out your answer. Okay, you think your part 2 is incorrect. Chelsea, your part 2 is incorrect. You think your part 1 is correct now. Ryan, you doesn't answer the question. Where were you for the past 20 minutes? I've been calling you at least 10 times. Where were you? Can you please later stay back and explain to me? Okay, let me explain part 2 to you. Since these two lamps are identical by right, based on Ohm's law, okay, they are both ohmic device. They are identical, they should have the same resistance. But what's happening here? Why is it that Q has a higher resistance now? Okay, let me explain to you. Okay, by right, they should have the same resistance, but why is it different? Okay, the reason was, can you see here? IQ okay, IQ is greater than IP. Okay, the current going through Q is greater than the current going through P. Okay, so why do we have different resistance? So IQ has a larger current. Okay, IQ is larger than IP. Okay? So this means that but Q has more current going through it. So it is operating at a higher temperature. Okay, so what happened? The filament okay, so for a filament lamp, as the temperature increases, the resistance increases. That's all. Is that clear? So even though the identical lamp, when there's more current, temperature goes up. When temperature goes up, the resistance will go up. All right. If you're clear about this last part, give me a thumbs up. Chelsea, are you okay? All right. So can you share with me for rating of 1 to 10, how much you learned today? Okay, how much you learned today? Okay, thank you, Yiting, you may go. Thank you, Chelsea. Thank you, Pei Kwan. Thank you, Oscar. Thank you, Ryan. Okay, thank you, everyone. See you all next week. Good night. Goodbye.